Hello guys, welcome to this video. In this video we're gonna talk about native VLAN. So in this video we're gonna make VLAN 10 for native VLAN in the fast Ethernet 023. This this one, the one that says VLAN native, and we're gonna make VLAN 20 for data and the name workers with the IP 192.168.1.1/24, and the ports goes from 3 to 10, and VLAN 90, and the name is IT management. This is for management the switch and the router, and with the IP 192.168.2.1/24, and the port fast Ethernet/24. So in this case we're gonna see some concepts. So the native VLAN is assigned to an AO2.1Q trunk port. Trunking ports are the links between the switches that supports the transmission of traffic associated with more than one VLAN. So it means that in this link there are traffic from different VLANs. Okay, and then says AO2.1Q trunks port support traffic from many VLANs, tag traffic, as well as traffic that does not come from a VLAN, untagged traffic. Tag traffic refers to traffic that has a 4-byte tags inserted into the original Ethernet frame header, which specifies the VLAN to which the frame belongs. Okay, so it means that when a packet is sent from this computer that is not in the native VLAN, when the frame is sent from this switch to the other switch, this switch adds to the frame a, a, a tag to the Ethernet frame. So that tag it's at when it's sent from one switch to the other and it's not on the native VLAN. So it is AO2.1Q tag. It's composed for 4 bytes, and it's composed for 2 bytes for tag protocol identification and TCI, 2 bytes. It's composed for 12 bits for VLAN ID. Okay, so then native VLAN are defined in the IEEE A02.1Q specification to maintain compatibility with untagged traffic from previous models. Okay, so it means that it is a standard and it is created by IEEE. So it means that this standard it can be used for different uh, brands like Cisco, Huawei, HP, Juniper. So any brand can use this specification, this standard. Okay, so then it is recommended that you configure the native VLAN as unused VLAN, independent of VLAN 1 and other VLANs. So it is very important that when you set up the native VLAN, you put the native VLAN in different than VLAN 1, because as default all the VLAN, all the ports are assigned in the VLAN 1. So if one computer wants to see the traffic from this, it can use a program or a sniffing tool to see the traffic. So it is very important to change the native VLAN to other VLAN that is not used in the network. So let's make the configuration. So for we have the configuration right here. So okay, so I have the configuration here to make the video faster. So the configuration from this switch and this switch are the same. The only thing that changed is the name and the IP address. So we're gonna go to enable configuration terminal, hostname, switch 1, then we set up the VLAN 10, name native, exit, VLAN 20, name workers, exit, VLAN 90, name IT management, exit, and then do show VLAN to see the VLAN. And then we put interface range facet 0/3-10 switchport mode access switchport access VLAN 20 exit, and then interface facet 0/24 switchport mode access switchport access VLAN 90, and then exit, and then interface facet 0/23 switchport mode access switchport access VLAN 10, and then we're gonna set up the trunk ports. These two ports are trunk because it sends different traffic from different VLANs. So we put interface range fast Ethernet 0/122 switchport mode trunk switchport trunk allow VLAN 10, 20, and 90. This command is to only allow the VLAN 10 and 20 and 90 in the trunk ports. And then we put switchport trunk native VLAN 10, so we change the VLAN 1 to native VLAN 10, and then we put exit, and then do write, and then we set up the interface VLAN 90. We put IP address 192 192.168.2.2 with mask 24, and then we put line bty 0 space 15 pass 12345 exit enable secret 12345. This is for 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 security to access to the switch using telnet or SSH. So you want to you this is not a good password. In a real world you need to use a better password. So we're gonna copy this and paste on the switch. Okay, so we're gonna paste. Okay, and then we see right now there's no error messages. We see that we create a balance. Okay, so then we can check out do show run to check out the configuration. So we see the fast Ethernet 1 is in trunk port, and then it's the native VLAN 10. So we see everything is okay. So right now we see that it is receiving a message that says native VLAN is matched on fast Ethernet 1. It is because we haven't set up this switch. So it is making a conflict between these switches because the native VLAN it's in different VLAN. So we need to set up this other switch. Okay, we're gonna change the switch, the name of the switch to switch 2 and the IP address. Okay, and then we're gonna copy this and paste on the switch 2. Okay, so we receive this message because we need to set up the same native VLAN on both sides. Okay, when we paste and then do write to save the configuration, and we put do show run to check out the configuration. We see that facet 1 is in trunk and the native VLAN is 10, and we see the facet 2 also has the same configuration, and we see the interface VLAN right here. We see that the IP address is 192.168.2.3. and subnet mask 24. We see the password. This is to enter to the switch using telnet, and we see the name that is changed switch to. Okay, so then exit and do write and write to to say the configuration to the NVRAM. Okay, so then we need to set up this router to this router. This is a router on a stick, so I have the configuration right here. This is the same as the last video. So we put enable conft host R1 interface fast ethernet 00 no shut interface fast ethernet 0/0.10 encapsulation .1q10 native, because this is a native VLAN, IP address 10.0.0.1, and the subnet mask is 255.255.255.0, and the same to the other interface sub interfaces. So we copy this and paste on the router. Okay, so we're gonna paste right here, and we see that there's no errors, so everything is okay. So exit, and then we see the name is changed to R1. Okay, and then we put write to say the configuration. Okay, so then we're gonna see the behavior of the native VLAN and tag VLAN and administration VLAN. So in this case, this is a native VLAN, and this is a no native VLAN. This is a data VLAN. So we're gonna test. So we're gonna put in simulation mode packet tracer. So we're gonna send a packet from this computer to this other computer on the other side. So we click on play, and we see the packet is sent, an ICMP packet, and then it goes to the other switch. So we're gonna stop right here. Okay, and we see right here the packet, that the frame, it's a layer 2.1q header. So it adds a tag to the frame. It adds a TP ID 0x8100. So this means I have right here, this means it's a VLAN tag frame IEE A02.1q. So it means it is tag, and the TCI is 0x0014. This is a hexadecimal, and if you translate to decimal, it means it 20. So when a packet is sent from this switch and to the other switch, and it is not on the data on the native VLAN, it adds a tag, this tag, to the frame. So we see right here that it is that this is the tag that we talked before. Okay, and then click on play to see what happened. Okay, so then we're gonna put this faster, a little bit faster. Okay, so we see that it receives a message, and also when it returns the packet, we see that also from switch to switch it receives a .1q header, and we see right here is that it is the same TCI and TPID. It is 0x is 0x8100 VLAN tag frame Okay, so then if we send a packet, so we're gonna reset simulation and we're gonna delete. If we send a packet from the native VLAN to this other VLAN, we're gonna see the behavior. So the packet is sent and then it passed to the other switch. Okay, so we see right here that the packet, it is an Ethernet 2, it is an Ethernet frame. It doesn't have tag, the tag protocol ID. We see the frame, it doesn't have the tag protocol ID. So this is the difference between the native VLAN and a tag VLAN. So the tag VLAN, when it sends a packet, the switch add a, a tag to that frame, but when we send a packet in the native VLAN, it doesn't add the tag to that frame. So this is the main difference between the native VLAN and the tag VLAN or no native VLAN. So then we're gonna see the administration VLAN. So the administration VLAN, it is just to check out the the configuration. So we're gonna see right here, we're gonna put telnet. We're gonna change to real time to make it faster. We're gonna put telnet 192.168.2.2. It is this switch. Okay, and then it asks you for a password 12345 1234 12345. Okay, so then we see we have access to the switch. So we're gonna put show run. Now we're gonna put show arp and we see the arp address. So that's the topic today. I hope you like this video and you want more videos, subscribe to this channel and thank you for watching. I hope you have a great day. Thank you.